11 and welcome to video number 8 of Pascal. This is going to be the last of these instructional videos that I'm going to do for Pascal, but if there is a particular question or something in particular that you would like me to go and have a look at, I can certainly go back and review anything that you need. I know I haven't done a lot of stuff with other types of variables, so if you want me to review those, I can certainly go back over them for you. All you need to do is ask. So I'm completely at your disposal, so to speak, being, housebound. Now, in Pascal, we have an ability to split our program up into different sections. This is normal for programming languages, and Pascal is able to do this in spite of the fact that it is not what we call an object-oriented language. In the hardware and software notes that you have in front of you now, one of the things that you will come up to is what are known as procedural programming languages and object-oriented programming languages. Now, a procedural programming language is like our HTML. If we go to any particular website, we right-click and click View Page Source. We can see the programming language there. I've shown you how to do this yourselves. And this is a procedural language. By procedural, we mean that one thing follows another in order. There's no moving about of different things. But one thing that we can do with procedural languages anyway is we can take pieces of them and we can put them aside to work in their own little way, in their own little time, but we have to give control of the program to them. So what we can do is effectively take a long and complex program and divide it up into smaller and smaller bits. Now, in your pseudocode, I'm not going to show you any pseudocode here. This is what you should be doing anyway. Your pseudocode and your flowcharts are designed so that you take a big program, cut it up into pieces, and each of those pieces becomes its own piece of pseudocode, and they can link together in a larger structure. In our programming, we can't do that quite so easily, but we have two things that we can use in our Pascal. One is called a function, and the other is called a procedure. Now, a procedure is simply a thing where we go and let something do something else. It's an easy way for us to break our code down into smaller bits so that when we're testing, we can have those bits worked on and examined themselves. We can look at the individual part and say, how does this bit work? And when we get that bit working, we can put that aside. We know that that works. We don't need to think about it anymore. And we can put some dummy numbers that are just for testing in there. And when we come back and put it all together, we'll expect that to work. It's only if we have actually changed how that piece will work that we will need to review it. So a procedure allows us to simply do that. And we will have a look at some code to do this. So I've already got some code. And this is the same programs that we have already seen. So I've called this one Procedures Original. And if you look, it is the last program that we looked at. In this particular procedure, we have our, and I'm just looking at my other programs that I can follow where I'm going here. If we have our standard little program that we just worked on with our while loop in here, and in our while loop, we have if the user health is equal to 0, or if the enemy health is equal to 0, then we have this little function happen, right? So if the user health comes in here, this little bit of our program would be an opportune piece to actually take out of our program and set aside as a procedure. Because what we can do is we can cut this piece of code and we can put it into a procedure of its own. Now, procedures in Pascal, like the remainder of the program, have access to our global variables. These variables here are known as global variables. They are variables that are accessible by the entire program. And they are accessible no matter whether we're using a procedure or whether we are using the main program. So what we will need to do first is we will need to define a procedure, and we define a procedure by using the procedure control word procedure. So we're going to call a procedure, and this particular procedure we're going to call, we have to give a name to. Now, when we break our code up, if you have a look at what this little piece here does, this little piece has two variables that it uses, just this little bit of code here. Right, we take this little bit of code out. So I'll actually open Notepad. I can't open Notepad++ because I'm using that. So if we cut this piece of code out and we put this in here, we see that we have one variable there and one variable there. These are the two variables that we are using in the program. So when we put ourselves into this procedure, we're actually going to have to pass these variables to it. Think of it as if we are handing off from one person to another to do something. If I ask Campbell or Darcy or something to go and do this little thing, like I am here, and they require tools to do that thing, then I have to actually hand them those tools. So in this particular case, we are doing the same sort of thing. We will have to pass this procedure some information. First thing we need to do, though, however, is give it an actual name. So in this case, we're going to give it the name find winner. So we're going to find the winner using this procedure. And that will be what we will call when we run this piece of the program. So we're going to find the winner and we're going to pass it some information. In this particular case, we want to pass it the user health and the enemy health. But those are variables that are already named up the top here. So what we would do is we would simply give them a name very, very similar. And in this case, the easiest thing that we find is to put an underscore so that we know what they still are. Now, they're still the same. They're still going to use the same information, and we're going to pass the information into these slots, and they are simply defined as variables the same way. And when I say defined as variables, we still have to use our variable command. So we are defining user health underscore and enemy health underscore as integers. We close our brackets, and we put a semicolon here. Now, procedures, because they are their own little program, they need a begin and end. And the end has a semicolon after it because this is a little program. So now we can simply move this piece of code in here from there. But because we need to match these up, we need to have our user health underscores and our enemy health underscore being in the right spots. So this is our little procedure, and that is what a procedure is. It's a piece of the code that's been taken from here and put into a different spot so that it will work on its own merits. Now, procedures, actually, I'll keep going here first. In order for us to call this, we need to actually ask for this thing to be run. Now, we can't really run it from the loop because it will run it every single time. So what we can do is after the loop has been ended, we can call this procedure from there. And we do that by simply typing in the name of our procedure, find winner, open brackets, and then we pass it whatever the information is that we need. In this case, it's going to be user health and enemy health. Close our brackets and semicolon. Now that will run as a function, and it will just run, as a procedure. It will run as a little program at the end of our program, as if we were writing, as if we had simply put these lines of code in where its place. So it's an easy way for us to break up our code, to separate this off and have it as a separate piece that it can work. A couple of things that are very, very important. First and foremost, the order of these variables must match the order of the variables that go into the procedure. That's very, very important because we don't know what these variables in here are going to be called. These are known as local variables. So these variables will only exist as long as this thing is being used. While we have access to our global variables, we don't want to use them. We don't want to play around with the global variables in the little procedure in case we change them. It's a place where we don't want them to be altered. So that's why we create a copy of them and put them in the local variables. Now, the order is important, as I said. Find winner, the first one is user health. The first one we pass it should be the user health. The second one, the enemy health. The second one should be the enemy health. And if we've done our thing right, when we run this, it should look exactly the same, as indeed it does, as our regular program. So our regular program here, when we run it, just says that our procedural health comes through it, and we seem to be losing a lot on this particular game, but nonetheless, it still shows us all that information, still goes through the loop until we hit to you took damage, and after you took damage, your health is 0, and then it calls this little function that looks the exact same as when we did it in our previous piece of programming. So that is a procedure, and a procedure, it's important to note, does not return anything back to the program. A procedure is not a part of the program where we can take something, do some sort of calculation, and then send that back. A procedure is just something that happens in the program. How would we do something that would actually be able to return a value? That is where we can use a function. So if we go here and I open my other program, and I will be putting all of these up on the Facebook, on the Google Classroom. You guys don't have access to my Facebook at all. I will be, this is our first program that we used when we wrote using read. And our using read program has a couple of things in here that we can work with for an actual function. So for example, we have these 4 lines where we can copy the information out and we can put them separately into its own function if I wanted to find, say, the full result of all of these. Now, a function is very similar to a procedure in terms of how it is drawn up and how it is used. So we, again, go up the top and write our function keyword. In this particular case, I'm going to call this all the math. And once again, we have to note that there are no spaces in function names. There are no spaces at all in function names. You have to keep it all as one word, right? In the same way that when you use random or read line or read, there's no spaces in those either. So here we're going to make a function called all the math, and we're going to have to pass it the 2 numbers. But instead of calling it number 1 and number 2, I'm going to just call them num1 and num2. I know what they mean. I don't need to worry about an underscore, but I have an understanding what they mean, and these are, of course, integers. Now, the interesting thing here is when we are using a function, we're actually having to return something. The entire point of a function, like a mathematical function, is to give you a result. This isn't a thing that happens. This is a thing that does something tangible and gives us back the result. So in this particular case, we need to define a return value, return style. So we put our defining colon in here, and we are going to return an integer. Yes, I have a thing for integers. And that is how we define our function. Now, our functions also have an interesting little tidbit, and in fact, our procedures do too. We can define local variables if we want to by using the var command. And that's what we are in fact going to do here. So firstly, we're going to define a variable called fn result. And that is where we are going to get the result of doing these different procedures. But we also want to have these different little procedures run. I don't want to reference the global variables in this case. I want to keep the global variables separate so they can run here. So I'm not going to use the global variables to put this, but I'm going to actually call my local variables very similar. For example, my addition procedure is going to be addi. My subtraction, subby. My multiplication, multi. My division, divo. And they are all going to be of type integer, because that is what our functions are going to do. So now we have defined our variables, our local variables, and these are going to be created and destroyed when that function is called. So this is an important thing to do. If you put a function in an if statement, when that program runs, it's not going to automatically set aside some memory area for these bits. It's only going to set aside memory locations for these pieces of material if the function is actually called, if the function actually works. So it's only when that function gets asked for by the computer that we're actually going to be sending information to it and recording information in memory. That's a very, very important thing to think about. And also, when this function is ended, when we hit the end of this function, then the function, all of these pieces of memory are destroyed. They are simply left to be overwritten. So you cannot reference any of these outside of a function. All you can do is have the function send a result back. So now we go into our begin and end. Of course, we have a semicolon. And now we have to do these same things. So addi is going to equal, semicolon equal. num1 plus num2. Subby going to equal, semicolon, a colon equal, num1 minus, no spaces, 1 minus num2. Multi is going to equal, colon equal, num1 times num2. No spaces. And divo is going to colon equal num1 div num2. Right. Now, this is going to run as a little procedure, a little program that's going to put our pieces in. But now we have to have our result defined. So fn result, our function here result, is going to come from us adding all of these bits and pieces together. Yeah. So fn result equals addy plus subby plus multi plus divo. And then we need to return this back. Now, when we return this back using a function, we call what's known as the exit command. Exit will close the function completely, and we put our result inside of this exit piece. So we're going to return whatever the value is of function result, and that will be the last thing that will be run by this particular function. So now we have a function there ready to go. But we need one more variable up the top here. We're going to have to add a variable to our global list. We're going to call it result. And that result is going to come in here when we call the function. So we're writing the addition, subtraction, multiplication, division. We've already got those down pat. They're all good. But now we want to write line. And we want to write result. And we are going to pass it the result integer that we've just set up. How do we actually get that? Well, we have to call the function to be able to make that happen. So when we call the function, and I'll scroll down so you can see this, we call the function by defining where we are going to put the results. Because our function is going to be returning something, it's always expected to be returning something, then we have to put a spot where that is going to be plugged. So we have to put a variable for this result to come into. So here we put our result is defined as, and then we call our variable, and our variable is called all the math. And we have to pass our variable, we have to pass our function the variables that are going to be called. So in this case, it's number1 and comma and number2. Close our bracket, semicolon. I think we've got all of our end lines there. Let's give it a whirl. I'm just going to clean this up just a touch so that it's a little easier to see. Let's give this a try. So we run the program, and here we have an error. So what is the error that I have put in there? I put integers instead of integer. So I'm sorry, that's a typo from me. I put integers instead of integer. And here we have I did not close this off and put a semicolon. Even the great people make mistakes. So that's our AVG. We don't want that one to run. Let's get the real one going. So we put in two numbers, 12 and 56. And the result of all these is 696. Now, if we want to say, well, I don't believe you, we can easily come up here and we can put some right lines in to be able to test if this is correct. So now, after each of these, let's put a right line, open bracket, addy, space, yeah, and we'll pass it addy. And let's test and see if we can make sure that all these results are exactly the same. multi, comma, multi, close bracket, semicolon, and open bracket, divo. And let's see if we can. So what we should have now is, as these are being called and as each of these functions happen, we should have their results put out to us the same way. So let's give it a try. We don't want to look at that one. We want to look at the proper one. And we're going to enter two numbers, so 15 and 62. And here we are. So our first number is 15, our second number is 62. Addition is 77, addition is 77. Subtraction is minus 47, subtraction is minus 47. Multiplication is 930, 930. Division is 0, division is 0. The result is 960. So you can sit down and do the actual math on that, but that is it. So we have here the same results as what's going on up the top here. And that is how we do our little functions. So in our functions, we need to use the exit final results. One last thing that I will say is the program itself, this main part of the program, is treated by Pascal as the primary function. So it's treated as the main function that calls other functions, which means you can use this exit command if you want to close the program. So if you have a spot in one of the exercises I've given you, for example, is to make your own choose your own adventure game. If you want to go through and do that, and for your end results, you want to have the program exit, you can use the exit command to close the program. There are plenty of exercises, and there will be more exercises coming up as we go through the program, through the next couple of weeks. I know we're about to start holidays, and I look forward to you guys having a little bit of a break. I need one too. I will be working on some videos on hardware and software shortly for you, and I'll hope to have some of those up before the holidays start. But if not, then I'll have them early next week. But this is the end of how to use Pascal. Now, as I have said all along, if you have any difficulties with this, please feel free to let me know. Send me an email, post up on the Google Classroom, and someone will be able to help you. If not me, then one of the other guys who may be a little bit ahead of us, they will be able to work with these things. But this is how Pascal works. I hope that you've enjoyed these videos. I hope they've explained things to you, and I look forward to any questions from you. So please keep working, keep engaged, and remember that Pascal, it should be your primary function process at the moment. Enjoy, and if you have any questions, hit me back. Thank you.